Writing factored form equations. Okay, so you're able to write the factored form equation of a graph function by following these steps. So I laid out some steps for you. Identify the roots, which is just like the x-intercepts of the function, and put them in the equation for r1 and r2, r sub 1 and r sub 2. And then pick a coordinate point on the line other than the roots. With these problems, I gave you that coordinate point. Plug it in for x and y, and then you can go and solve a. And then you just got to rewrite the equation. So it's kind of like writing the equation in vertex form. It's very similar to that. So here we go. Let's just get on with the example. I'm going to try to write this in factored form. So in factored form, remember the roots are given. So let's identify those roots first. We have a root of 3 and a root of -4. So as I'm writing this equation, I'm going to do opposite of those roots. So I'm going to do x plus 4 because it was a -4 root, and then an x minus 3 because it was a positive 3 root. So that's half the battle. We got most of the form of the equation done. Now we just need to figure out that a value. So just like when we were doing this with vertex form, in order to find the a value, we're going to pick another point on the graph, doesn't matter which one, and then substitute it for x and y and solve for a. Now it gives us a point, so let's just use this one because a lot of times with these, they don't cross nicely some places. So I'm going to use that point they give me. So -20 is y. And then 1 is x. Now let's do some simplification here. 1 plus 4 is 5. 1 minus 3 is -2. Rewrite that. -2. Let me zoom in a little more. And then rewrite the -20. 5 times -2 is -10. It's -10. So I'm going to put the -10 because a is being multiplied to the -10, but I'm going to put that -10 in front as our coefficient because, typically write that number in front. And then to solve for a, I just need to divide by -10. So divide by -10. 2 equals a. So to write my final answer, it's y equals 2 parentheses x plus 4, x minus 3. There you have it, in factored form. Okay. Let me show you number 2. First step, identify the roots. So we got a root at +1 and +6. So as we are writing this, I'm just going to write a as a placeholder right now. Since it was at +1, we're going to do the opposite. So I'm going to write x minus 1. And since it was at +6, I'm going to do the opposite. I'm going to do x minus 6. All we need now is a. So in order to solve for a, we're going to pick another point on the graph. One is given to us, this 5, 12. So I'm going to put 12 in for y. And then I'm going to put 5 in for x. Rewrite my 12. 5 subtract 1 is 4. 5 subtract 6 is -1. 4 times -1 is -4. And I'm going to put that -4 in front as a coefficient of a. Rewrite my 12. Divide by -4, and I should get -3, right? So if I divide by -4 on both sides, I'm going to get -3 equals a. So now I can write my equation. My equation is going to be y equals -3 for a, x minus 1, x minus 6. So those are the steps. So I'm going to let you do the rest of the graphs. Let me show you one where it's just in a word problem. Okay, but it's the same concept. So it says write a quadratic function to represent a parabola with roots of -3 and 2 that passes through the point -6, 120. Okay. So when you use quadratic function and it gives us the roots. So of course, we're going to write it in factored form because factored form shows us those roots. So we're going to write y equals a as a placeholder. Now it's got a root of -3, so I'm going to do a +3. It's got a root of +2, so I'm going to do an x -2. So same thing with the graphs. Same exact method. And now it gives us a point, right? -6, 120. So I'm going to put in 120 for y because that's the y coordinate. And I'm going to put in -6 for x. And then I'm going to solve. -6 plus 3 is -3. Sorry if I'm going fast. Okay. -3 times -8 is 24. So it's going to be 24a equals 120. And if you divide by 24, that should be 5. Yeah. Divide by 24 on both sides. A is 5. So my equation would be y equals 5, x plus 3, x subtract 2. Okay, so that's it. I'll let you do the rest of them, but that's the idea behind it.